In this video, we are going to discuss the very basics of linear algebra for data science. Now, a data scientist must know some maths to understand how algorithm works. Linear algebra is often ignored by data science students due to the complexity of mathematics. But in reality, it is a must-learn topic. Linear algebra is a vast subject in itself. We do not have to deep dive into it, but we should understand the basic math in order to be a good data scientist. So that is the use of linear algebra in the data science, that by definition it is actually a branch of mathematics which involves the study of lines, planes, vectors, matrices, and equations. It has a wide role of application in data science field, and a glimpse of which we are going to discuss in this video. So the question might arise that why should we learn linear algebra? Now we can easily visualize the 2D, or we can say the 3D data. When I say these terms, then you can visualize actually that okay, such kind of things will be 2D and that will be a 3D. But what about if I say you 4D, 5D or 10D? Can you visualize such kind of data? Normal human eyes can't visualize more than 3 dimensions. But in reality, some data scientists need to work with hundreds of dimensions of features, we can say. Here linear algebra comes into play. Even if we can't visualize such huge dimensions, but we can still represent them in form of matrices or vectors. For example, we can find distance between 3 points using the square root of a square plus b square plus c square. Like this, we can represent n points also. Sometimes we also decrease and increase the dimensions for better visualization and analysis also. So the first thing which we are going to discuss is vectors. Now vectors, linear algebra deals with vector spaces only. A vector space is a set of objects called vectors. We can add or multiply vectors. A vector is a list of number. It can be thought of as a point in space which is numerically represented in a form of list. Now vectors are of two types, that is a row vector and a column vector. Row vector is having one row and n number of columns. That means its dimension will be 1 cross n. Whereas column vectors have n number of rows and only one column. So its dimension will be n cross 1. Now when we come to vector addition. Simply vector addition, suppose you have two vectors. Let's say A is equals to 1, 2, 3 and B is equals to 3, 2, 1. Now if I say I want to add both the vectors and then put it in a variable, we can say another vector C. So C will be basically the addition of 1 plus 3, combiningly the first element, 2 plus 2, second element, and 3 plus 1, the third element. So this sums up to the vector addition. Next we are going to discuss about the vector multiplication. So multiplication, we have to multiply the vectors using the dot and the cross products. So cross products are not widely used in machine learning. We only use the dot product. So what is in the dot product is, let's say we have an A vector which is 1, 2, 3, 4. And we have another vector which is B and it is having 1, 2, 3, 4. Now here you can understand one is the row vector and another one is the column vector. Now the dot product of A and B will be like this. A to the modulus of B cos theta. Now what is this cos theta? Theta will be actually inverse, cos inverse this whole formula. That means it can be written like this. Now it is actually a projection to the unit vector. And how is it done? Let's say that this is the axis which are there. And this is the dotted line. So distance is basically A cos theta and this is the D which is there. D is actually the projection of A on B. So this we can say as B and this we can term as A. So D is projection of A on B. We can say of A vector on B vector. And this is the theta which is there. And this is the 90 degree. So this is the projection and the unit vector which is there. We have discussed about vectors. Now we are going to discuss about plane. Now plane, we can say the two-dimensional axis x and y is represented by a line. We know that x and y coordinates if we have, then this is a two-dimensional axis which will be there, and that is actually of a line, we can say. 3D axis, where there is a 3D axis, that means there is an x, y, and along with that there is a z also, is represented by a plane. Similarly, n dimensions are represented by hyperplane. So there we have 3 dimensions only. If we have n dimensions, let's say, then they are represented with the help of hyperplane. Now we know that the equation of line, that is y is equals to mx plus c, where this c represents the intercept, the y-intercept which is there, and this m actually represents the slope of that particular line. So the equation of plane in n dimension is actually wtx plus equals to 0. Hence the equation of the plane passing through the original, that is wtx is equals to 0. Here we are using w transpose because by default it is represented as column vector. We convert it into row for the multiplication. So normal plane is represented by a vector perpendicular to the plane. So like this you can say this is a plane which is there, and here we can say this is a vector which is represented. So W is a vector which is perpendicular to this plane, we can say. What will be an hyperplane? And hyperplane will be a figure like this. A particular figure like this can be said as an hyperplane when there are n dimensions which are there. So we have discussed about vectors and planes, and lastly we are going to discuss about matrix and implement a very small program to see actually the matrix calculation with the help of NumPy library. So you might all know the definition of matrix also, but still I would like to recall you that it is an array represented in form of rows and columns. We often deal with matrices while performing or applying algorithms in machine learning also, operations like addition, subtraction, multiplication, transpose, etc. Sometimes we get similarity matrices of huge data. Then normal human visualization is impossible. Then only we use the linear algebra. So we can say an eigenvalues and eigenvectors for matrices whose application lies in the principal component analysis also. So what we are going to do next is just implement a very small program for the addition of two matrices, subtraction, multiplication, and then the product of the two matrices also, and then see the transpose. Transpose is nothing but replacing the rows with the columns. So let us see the implementation of the very basic code. So what I'm firstly going to do is I'm going to import NumPy, and then I'm going to have two arrays, two NumPy array I'm going to initialize, that is x and y respectively. So here you can see that I have done the import first, import NumPy as np, and then with the help of function np array I have created the two-dimensional arrays which are there, having the elements as 1, 2, 3, 4 in x and 5, 6, 7, 8 in y. Then comes the addition of two matrices. So for that you have to write like this, print, and you have to add np dot add, and you have to give the arrays which are there, that is x and y. And as you execute this particular cell, you can see the addition of the elements which are actually there present in both the arrays. So this returns you the addition which is there, that is 6, 8, 10 and 12, the addition of the respective column wise which is there. That means we can say 1 plus 5 equals to 6, 6 plus 2 tends to 8, 3 plus 7 10, and 4 plus 8, that is 12. This is how simple addition is done. Next, if you want to print the subtract of both the matrices which are there, then you have to write like this, np dot subtract, and you have to give x comma y. So you're going to get negative values also. So negative values of subtraction is given in the matrix which is there. Next, you have to see the multiplication of both the matrices. So you have to write like this, np dot multiply, and here you have to give x comma y. So this gives you the multiplication of both the matrices which you have given. Next, what you need to do is, you have done the addition, the subtraction and the multiplication also. Then you have to do the product of the two matrices, that is with dot. Dot product you want to see, the cos theta formulation which we actually did. So for that you have to simply write like this: print np dot x comma y. So here you can see that this returns you the dot product which is there. And if you want to perform transpose of any matrix, then you have to simply write like this: print x. Let's say the first matrix which we have was x, so we will print the transpose of that only, and then you have to write the capital T which is there. And as I execute this particular cell, now you can see the matrix has been changed. Earlier you noticed that when we printed the first matrix which is there is actually 1, 2, 3 and 4 which is there, but now you see 1, 3, 2, 4 is the matrix which is there. That means the rows and column has been interchanged and transposed. So this is about the basic linear algebra. You can also find this particular tutorial written in our official website, and the link will be given to you in the video description for your reference.